All right, we're going to start this section in 11.2 on vectors again. We're looking at the trig form. Let's hit it. Let's get right to it. So if I got 2 points, P1 and P2, the vector from P1 to P2 is, I'll call V. It's got some magnitude. And if I want to find a unit vector in that direction, what I can do to do that is take the magnitude of V and divide V by it. So unit vector, in this picture, I wrote U. The unit vector U in the direction of V is obtained by dividing V by its magnitude. So, and this is called normalizing the vector because it's still pointed in the same direction, still originating at the same spot. We're just finding a vector of unit length of 1 there. And so we either divide by it or you're multiplying by the reciprocal of the vector. So let's go through and look at this individual point. We started at 1, 1, and we go to 4, -6. So I calculate the length of V. Well, I calculate V first. 1, 1 to 4, 6, 4, -6. You do 4 - 1, -6 - 1. The vector V is 3, -7. To find the norm of the vector, we take the sum of the squares of the components and then take the square root of that. 3 squared and -7 squared is 9, and 49 is 58. So we have the square root of 58. So we're going to, I don't know why I have an equal sign there. We're applying 1 over root 58 times the 3. This looks funny. So 3 divided by root 58, -7 divided by root 58. That doesn't belong. That was a miswrite. Does this vector have a norm of 1, a magnitude of 1? It's not clear looking at it unless you're quick at it, but you can always calculate it out and verify it. So we square each. 3 over root 58 squared is 9 over 58. -7 over square root of 58 squared is 49 over 58. We add them together. We do see that we get a 1. Okay. More stuff we do with the trigonometry in vectors. If I have a unit vector starting at the origin and going that way a length of 1, I can see from trigonometry the length here, the x component is this side here, the y component is this side here. Using a little bit of trig, cosine is adjacent over hypotenuse, x over 1. So we can see that x equals cosine theta. Same thing with doing the sine. Sine is opposite over hypotenuse, y over 1 for a right triangle. And so we just get y equals sine theta. And thus, instead of writing u equals xy, I could write u equals cosine theta and sine theta. Well, that's doing the unit vector. What happens if we scale that up with a scalar? A regular vector v is just a unit vector multiplied by some scalar. And so how do we figure out what that is? Well, if we look at the picture here, rather than doing x and y, we have k times x, k times y. This length is 1. Well, 1 is being multiplied by, it grows to k. K is now the new length of that vector. So that's how we scale it. K goes in there, k goes there, and we've got b is k cosine theta, k sine theta, where k is the magnitude of the vector. So we could rewrite it like this, putting the vector magnitude out front, or we can write it inside. The norm of v times cosine theta and the norm of v times sine theta for x and y. This does not translate to 3 dimensions well. So I would stick with doing the trig form like this. We will do some forms that have some trigonometry in there. And so let's do a little bit of work. Let's take a look at an example. If we've got the vector 2, 2, can we write it out in the norm and cosine theta, sine theta form? What is the norm? What is theta? So we do the norm. We just take the norm real quickly. Square root of 2 squared and plus 2 squared is the square root of 8, or 2 root 2. If you've forgotten your trigonometry on finding theta, it's tangent inverse of y over x. So tangent inverse of 2 over 2 is tangent inverse of 1, and that's pi over 4. Hopefully you remember your trig angles and stuff like that, because that's going to come up a lot. So we would write b as this: 2 root 2 times cosine of pi over 4, sine of pi over 4, or we can move the 2 root 2 inside. And that'll bring a close to this section. Peace.